regression.
Oh, that was on the part.
Linear regression? It's convenient that the park test has a lot of modeling on it, but yet you haven't seen any modeling. Go figure.
It did.
Good chance it'll be after this video.
Yeah, it was like model this piece, draw pictures.
I'm not sure if you're just
I
making
literally thought it was asking for a picture.
It probably is next.
Yeah, we were talking about boxing. I'm
So we have types of remember types of correlation. Correlation is if you could draw a line of best fit into a data set. And if we're talking about it in terms of linear, that means we're trying to find a best fit line. Convenient, instead of a best fit curve. As we go through this, we're going to talk about best fit for lines, quadratics, cubics, polynomial functions, exponential, logarithmic, as well as trigonometric modeling. There's a lot of different things. Sinusoidal models, it's really cool. A sinusoidal model is a really good example. Temperature fluctuations throughout the year, average temperature. Isn't each year?
That was on the part. That was on the part. That was on the part too.
Wow.
Wow, that's on the part.
And it had like January, February, and it had all of them. And it's like, well, month one is January, so
It is a sine graph. Or it's a cosine graph shifted 90 degrees.
It was yes.
Oh, but
I had that
So you're telling me that next year I should probably do more modeling throughout the units, so that way when you come to the park test, you guys will see it? Yes, ma'am.
The park test was exactly the same as last year, except this year they took away the option for you to add in your suggestions and improvements.
I remember that from last year. That's when Caleb really wrote out some good stuff. Over. That's all I gotta say, right? Yes, sir.
So one of the questions on the thing, they had this equation. They're like, oh, so this lady's Wi-Fi costs like X, or like this amount of money, and then plus this amount if she goes over her 5 gigabytes. But the way they had the thing set up is that if she used less than her 5 gigabytes, it would reduce the cost of her Wi-Fi bill. And they said in the problem that you couldn't do that. It was totally, like, they're like, you pay a flat rate of this. This equation represents how much it costs. And it's like, well, if she uses 4 hours then, or 4 gigabytes, then her Wi-Fi costs less, and you said that it can't cost any less than this.
Well, no, it's assuming that it's gonna be, this is your minimum cost.
Yeah.
That will be your minimum cost no matter what. That's all that implies. But anyway, when you're talking about lines of best fit correlations, there's only really 3 different ways to look at it. You can have a positive correlation, a negative correlation, or dun dun dun.
A neutral.
A neutral correlation.
All right, I can give you neutral correlation. It's kind of the same thing. There's no correlation in the data sets itself. Bless you. It doesn't look as if there's any line of best fit that you can put to it. For example, if I want to look at a positive correlation, if we're thinking in terms of lines, what direction would the data set be going? Up and what way?
Right.
Correct, because it's slope. So if I'm looking at a positive correlation, it might be doing something like that. Bunch of data sets moving up and to the right. What would a negative correlation look like?
Down and to the left.
Frowny faces.
Down and the right.
Down and to the right.
Same thing.
Correct.
Oh.
I really appreciate it.
Yeah. Yeah. And then no correlation or neutral correlation.
Is it false positive?
How's it going this
Or
way?
the false negative. I didn't get this.
Because this way is going this.
And people be more likely to.
And then no correlation might be
They had this.
no. Down and to the left, the same thing as up and right, isn't it?
Yeah.
So no correlation would be something where it's just a data set all thrown in the middle and you can't show that it's increasing or it's decreasing, increasing to the right or decreasing to the right. It's not showing that it has a positive or negative slope. Okay? That's what we're looking at. You've actually worked with these before. You've taken data sets and plotted them via scatter plots, because that's all these are. and written out the equations of the lines. So that's kind of what we start out with this stuff with. So real fast, do you remember how to write the equation of the line given 2 points?
Y equals mx plus b.
Well, that's for slope-intercept form, but what do you do when you have 2 points?
Y minus y1 equals x2 minus x1.
In other words, you have to get the slope, and then you use point slope form. And then you'd solve for y.
Oh my God.
Hey, and guess what this looks like?
Nightmare, something you can never escape.
Oh my god.
It's a point slope form, ladies and gentlemen, is A, H, and K for lines.
Hey, that's our amplitude
I saw that on
and
this.
vertical and horizontal.
It's your horizontal and vertical shift of a line. It's your slope. Same idea. So this is the same thing for lines. We just never wrote it that way. Okay. So let's. I'm just showing. This is point slope form. I'm just showing that that's what that meant. So let's do a real quick, easy data set.
Easy.
Let's look at the data set of height versus weights. And we're going to write an equation, a line that relates height to weights, and then figure out if it's true and see how close we get. So we need tall people and short people.
I'm pretty.
How tall are you?
I am 5'8".
So that's 60 inches.
Whoa.
How much do you weigh? 99 pounds.
You don't ask me.
What?
I need somebody else that's taller than 5 foot. Yes!
5'3".
So that is how many inches?
62.
63. 115.
I need somebody else.
6.5.
5'6". You are 66.
And a half.
Ah, it's close enough.
My name was
115? Okay.
6 foot.
No, you're
Whoa,
not
no,
6
whoa.
feet. You are not
That's
6
so
feet
good.
tall.
Oh my God.
You are not 6 feet tall.
He's 6 feet tall.
What?
I'm 6'3".
Where's your
Wow. 6'3".
How are we supposed to know you're 6'3"?
I'm 5.
He's 5'11".
Miss Jasmine, you're taller than that.
He is not 6'3".
Eric
Taller
is
than
not
me.
I
tall.
don't think he's 6'3".
Wait, never got beard.
There's no way you're 6'3".
Oh, I thought you were taller than me.
Jasmine is taller than Eric.
No, it's not.
Oh my god, you're 6'3".
How much do you weigh?
165. Dave,
He's
boy.
like 140. He's a string bead.
Miss Jasmine? All right, so we've got some short people, some tall people. I mean, you're medium height-ish.
I mean,
Oh, I'm saying Eric.
Well, I don't want you then.
I'm 5'10". I weigh 130.
14.
I'm 5'3".
And
5'8".
this is too much math.
You're 5'8".
Yeah, I'm short.
I'm 5'8".
What?
I'm 5'8".
No, he's just a little bit taller.
No, I thought
Yeah,
I
he
was
is.
taller. No.
It's his hair.
No, his eyes are higher up.
Yeah. Well, then just.
And how much you weigh?
170. Small forehead.
170? So with this data set, with this real basic data set, we can turn it into a scatter plot. You guys remember doing that?
Yeah.
So let's do this. Let's put height on the x-axis and weight on the y-axis. And let me split this into 2 screens so we can kind of do this normally.
Wow, you're
Fancy. Are you okay?
I'm okay, thanks for asking.
Oh, okay.
Now, what we need to do here is come up.
I like it.
We're going to come up with some sort of a scale. So we have the height and weight. Get it? Scale.
in height.
Yeah,
I think it's funny on the
So let's do this. We did all of our height. We kept all of our height in inches. So let's just count it out by 12s and come out, what, 7 of them? So So 1, 2, 3, 4, 5, 6, 7. We okay with that? So I'll just call that 12, 24, 36, 48, 60, 72, and 84.
I can't.
You said you
Wow.
girl.
They're winning numbers for tonight.
Can you get one of their outfits?
I look great in sequence.
Oh, great. And serious.
Oh no. No, tie.
And
Hey,
very shoes.
Arithmetic or geometric?
Boo. Weights. If I started at 0 and worked my way up, we'll say, let's go between 0 and 200.
200.
What would be good break points you think to mark it off?
10,
Five.
25, twos, 25.
What,
15.
what if I did 50s?
I just said 50.
I didn't hear you.
Speak up.
5, 10, 20, applesauce.
Next.
I would start at
You want to start at a higher number?
What's that?
When you want to start at a higher number, there's like everyone between 60 and 72.
You can, but then you have to worry about your scaling then, okay? What I'm trying to do is start it at a 0. You can adjust your scale.
It's hard to find a pattern.
Well, once you start plotting things out, you're just looking at a rough scatter plot, okay? Now, the other reason why I'm setting it up this way is because eventually I'm going to show you guys how we can create these tables and lists in our calculators and change the windows so we can see our actual graph. So now we're just going to go ahead and plot out some rough idea here. We have 60 and 99, 63 and 115, 66 and 115, 72, 165, 71, 140, 70, 130, and what is it? 68, 170. Yes, ma'am.
Do you ever watch the show Little Big Shot?
No.
There's this kid on it, and he can like double numbers, and it's like crazy.
Oh,
Like he was like 6, 12, and then like he like kept going, and it would do like 1,000 something something.
Is that in the Steve
That's-
Harvey show?
yeah.
That was on my Facebook. I don't know, some person great post that. I was like, why am I seeing this?
But you should watch it because it's really cool. Bro.
Yeah, it's like this little like 8-year-old kid who's like, use the calculator. And then he's like, I bet I can beat you. And he's like, 6, 12, whatever goes in. 24, and then he ends up getting into the thousands. So he ends up with 38.
Great. Anyway, so if I'm looking at this, our data set seems to be a little bit skewed in the middle here, but it appears as though it's kind of doing this, right?
Right. Thanks, home is over.
So, yeah, the anomaly here. So what I want to do is kind of get into a rough idea of what I think might be the best fit line. So what I'm doing here is I'm trying to place this line on this that encompasses the most data sets that show that it might mirror itself out where there's enough on both sides, taking into consideration some of the outliers, Cooper, about heights and weights and stuff like that. Anyway, so what I might do is I might actually pick, I'm almost thinking about, with the way that these numbers are bunched, I might pick these two as my data set. I might say that those might be my best bet. Everybody okay with that?
Yes.
So if I do that, I'm picking, what is that, the 63, 115?
That's me.
And then, what, the 72,
No, the
What?
71.
71, 140? It looks like I'm picking those two values. So let's pick those two numbers and write the equation of the line. Now, when we do that, remember, our ordered pairs are going to be 63, 115, and what, 71, 140? And I'm going to do the change in y over change in x. So 71 minus 63 over 140 minus 115. 7, 8, sorry, not as good as that kid. And then, what is that, 25? So I have a slope of 8 over 25. Now when I go to write the equation, then does it matter which of the two ordered pairs I choose to write it out? No. So I'm going to go with point slope form here. I'll go to a clean page so you guys can see where I'm going here. So I have a slope of, what did I say, 8 over 25? So y minus, let's use 71 and 140. So mod minus 140 is 8 over 25 times x minus 71. So it'd be 8 over 25x minus 8 times 71 over 25 plus 140. So I just got to figure out what that is. So I use my calculator. 8 times 71 divided by the negative 25, add 140, and I get 8 over 25x plus 117.28. That's what I'm getting for an equation. So that means if I take somebody's height and I put it in, substitute in for x, I should get approximately their weight. So who didn't we pick on? How tall are you?
5'10".
5'10" and a half. 8 times 70. Yes, I'm racist, Felix. Divided by 25 plus 117.28. Do you weigh approximately 140 pounds?
Yes.
Hallelujah!
Magic.
Iotis, please tell me, would you oh so kindly, how tall are you?
6.
Iotis, are you about 140 pounds?
Yeah. Sorry. I will only do 45.
You gotta make sure it's negative. Yep. What do you want? 5'6". So you are 66. So if I do 66 times 8 over 25, and I add to it 117.28, are you about 138? See? It's math that's useful.
What?
I know.
Yeah.
I know. And that's the idea, guys. What we've done here is we've just kind of done a quick, rough idea. Obviously, with a small sample set. Now, if we did it for everybody in the classroom, we'd get a better setup. So let me show you how to set this up via your calculators. But you need to know how to use regression.
I didn't know what you were saying.
I don't either, Cage.
This review shows us with that one.
So take out your calculators. Let me show you how to work, how to set this thing up with our data sets. Let me go back to our data. So in your calculator, first thing I want you to do is we need to clear out. Yes, in the cabinet. First thing you have to do is clear out the lists that you have. So you have to hit second plus sign 4. Hit enter. Done. Go to your y equals. Clear out anything that's in your y equals. You got to clear all that out also then.
Oh, then just press.
Second plus plus sign.
Okay. Now, what we're going to do is these next steps are going to be the same steps for entering lists, whether we're talking about linear, cubic, quartic, whatever. Any of these functions we have to use a calculator to create a list, we do the same thing. We hit, well, we got to back out first. Hit stat,
Stat.
and then hit enter. Bless you. Stat's right in the middle.
Stat.
And then hit enter for edit. And you want to enter into L1. And what do you think we're going to put in L1?
Number.
Why?
Heights.
Heights, yeah.
60.
Enter.
60. Yeah, 60. You can enter or down. It works the same. Over, under. Then we got to go to the next. Hit right to get to L2.
Now what? Now what?
Relax. Uh-oh. Screwed something up. At 72, I have somebody at 305 pounds.
Eric.
Eric, Cooper. Wait, Eric, you're happy about being 305 pounds? I am.
Eric's wall.
It's all that much up we got. So it's very easy to screw something up like that, so just be careful, okay? So now we want to go and back out. So hit quit.
Did all that work? Awesome.
Now go to second stat plot, which is y equals. Second y equals. Next to second one. Okay. Now on here, you want to make sure that your stat plot for plot one is on. So if your cursor's on that, you just hit enter. And you want to make sure that you turn it on. Then you have a bunch of different graphs to choose from. We've got your regular old scatter plot that'll draw the lines connecting it. It'll do bar charts, box and whiskers, all that stuff. The next options are what's your x values, what's your y values. So we chose our L1 to be our x values or our L2 to be the y values. You can change them however you want it to go. And then mark it as a little open square, you can mark it as a plus sign, a little dot, whatever. And you then can change the colors. Some of you can.
I can't.
Blue.
Magenta was a big fan of third out too.
Magenta.
Okay.
I wear magenta.
Now with the screwball thing now that happens is that for all of these different scatter plots and lists, you have to adjust your windows. So just like we did a second ago, we sat there and we created some sort of a scale for our scatter plot for our own reference. We chose our x minimum at 0. Our x maximum was 72, I think.
Yeah.
0.
No, 84.
84, thank you. And then we went by each marking that we put in, we went by 12 inches. We just changed, that's what Y scale stands for. Sorry, X scale. Okay.
What is actually?
12. So that means each marking it puts on the scale is going up by 12s. Okay. Do the same thing for your Y max and min. The Y minimum was 0. Our maximum, I think we set it at 200.
Yes.
Yes.
And then our scale went up by 50.
Correct.
All right. With any luck, if you hit graph, it should show up. It's the resolution of how dark the dots are going to be. That's all. It's okay. Everybody get something that looks like that?
No.
Yeah. And then you screwed up.
Look, hey, I'm not big.
What did it say?
The graph.
You have nothing in your lists. So if we go back and look at our graphs that we did, Hey, look at that. That's pretty close, isn't it?
Oh,
Hey, it's like we knew what we were doing. It's scary.
almost like we
But wait, there's more. Go back and hit stat again,
Why do we want to keep going to stat?
because that's where all the buttons are. The most important button that we're going to look at today is called calculate. Just hit over to the right where it says calc, C-A-L-C. And what we're working on is we're working on linear regression AX plus B. Option 4. And it's asking you, what do you want your X values? Our X values are L1 because that's where we put them. Our Y values.
They didn't do that.
Oh, some of them do, some of them don't.
Mine did.
If you just hit enter a bunch of times, it should work.
No, mine did like, it went to where you get calculated.
Did it go right to that then?
Oh, it just went to
Yeah.
mine, didn't it?
Mine just went
Hit
like
enter.
this.
Hit enter.
Oh, there we go.
Hey.
What do you think that A stands for?
No.
Awesome, you're right. No, it stands for slope.
Slow.
Because here is now our equation. This one has the regression differently from what we did. The calculator is coming up with the following equation. Y equals 4.652x minus 178.9, roughly. So if we substitute in our heights into that one, see how close we're again. Okay? Let's see. Where's my calculator? Thank you. So if I do this, oh, we used to be able to send it there. Anyway, so if I do, who did we do yet? Well, what's your height? 4.652 times 68 minus 178.9. 137 and change? Is it close-ish? That's what we're looking at. Okay. 4.652 times 175. Well, it says I'm 170, so
Oh, that's my
it's close. It's close-ish. I'm actually 185, so
15 off.
I mean,
That's fairly accurate.
Why'd
I
you
mean-
slap your foot? I mean,
well, I get the wrong person.
Wait, Mr. Murphy, is that how those people at the carnivals and stuff are able to guess people's weight just by looking at you?
They just pull up their calculators like, you want to give me some?
They're actually scales in the ground that they're walking on.
Oh, really?
Yeah.
I thought they were actually guessing. It's like Monday at Santa Claus. There's scales on the ground.
Matt,
What did you say?
You know better.
Can you guys try some of these on your own?
What did you say?
no, I like the one where they like lift them up. They're like, and they like shake them up like 130.
Yes, sir.
Wait, so what's Chapter 2,
The test is just give you a lot of these regressions out. And what we've done, this was a new unit that we taught last year. We actually have a really good packet we give you guys when we start putting all this together about how do you identify certain things from graphs. A lot of it is graph recognition. Remember, it changes direction, it actually helps you decipher degrees of polynomial and whatnot. Yes, sir. This is on page.
Oh, okay.
It's section 2.5. I want to say it's 114, I think. 214. Yes, ma'am. It is. I just uploaded it there. If you give me a second, I can look and tell you what page it's on. Or we wait for Carter to get to it eventually. 103. Starts on 103.
Yeah.
Yeah, so it starts on page 103.
It's Chloe's birthday.
Oh my God.
Is it your birthday?
Tomorrow.
It's Chloe's birthday.
Which one?
Chloe, remember?
Oh, I don't know.
Okay.
So that means we got to make KJ a crown.
Oh, wait, can we make one for Hitler too?
Oh,
Yeah. It's his birthday tomorrow.
It's dead. It's in the ground. Actually, it's burned up, but still. They can't make it birthday.
Yeah, I don't know if that's what we celebrate normally. That's probably
No,
not.
and it's not 1 year anniversary of
I got a puff yesterday. Oh.
Or not yet, one more. Like,
Everyone
Tuesday,
wears
like,
meat
99.
tomorrow.
Oh, down my one. Yeah.
Did you just
Wait,
say
what?
meat?
Sam, do I have to call Lockhart? Give me a second.